Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today is another installation of the same problem. You remember that this was our results, and if we're pointing straight across, we actually drifted down the distance L downstream. And this distance L turns to be 200 meters with those numbers, and time is 6 minutes to cross. And of course, if we don't want to be drifted down, because if we drifted down, then we have to walk, right? Or if this is like a ferry, and it brings us not here but here, and the road continues here, we have to drive, right? So we obviously have to aim a little bit here with the same speed though, but we have to aim a little bit higher. And we have aim at an angle alpha that they want us to find out what is the angle alpha. And then if we aim here, then there is like a point here where we're aiming. Let's put this point, D is taken, L is taken, let's put the point S. This is S. This would be S. How far upstream should we point against this point? This is A and this is B, they're all perpendicular, right? How far, so that being moving with the same speed V, right? This is the same vector, the same length, but it's pointing at the angle alpha, so we arrive at that point. And initial idea would be, if we drifted down L, we should point S should be equal L. That's like an idea. If it's true or not, let's find out, because this sounds reasonable. Instead of, if we're pointing straight perpendicular to the river, we drift at this distance. Or let's point a little bit upstream the same distance, and then we come to the point that is straight around. And I don't want to solve it with one linear motion. Let's solve it with x and y. And so let's say that y is, and here is, before even going, I say that if this is the speed v and this is angle alpha, that this vector v has two projections. One projection is vy and another projection is vx. And vx, if this is angle alpha, is v sine alpha. Again, this is from this triangular. This is vy, this is vx, and this is v. So this multiplied by sine alpha is this vx, and vy equals v cosine alpha. And those two. And if you have trouble with those, please go to my trigonometry playlist or to vector playlist and find how you find projections of the vector and what is sine and what is cosine and how they related to the triangles. So we have y and we know the speed. The speed would be v cosine alpha multiplied by, let's put it t1, because time 1 would be different, it would not be the same. And we will see why. So v cosine alpha by t1. And what about x? X, there are two speeds. One speed is u and another speed is this. So minus v sine alpha. And t1, and obviously x has to be 0. So we should not be moving at all in this direction. So we can straight away forget about this time and say that u minus v sine alpha equals 0. Right? U minus v sine alpha equals 0. And basically what we don't know T1 and we don't know alpha. We have system of two equations and we don't know y, because we know y actually. Y is d. So d is given, v, u, v sine alpha. So we can try to solve it, but this is cosine alpha, sine alpha. Let's try to solve it from here. Let's say u equals v sine alpha, and sine alpha equals u over v, right? And we can put it here, cosine alpha. We put the sine alpha here, alpha. First of all, we immediately find alpha, what they ask us. Sine alpha equal u over v. And I can put the numbers right away, but I can say that it is 0.u to v 0.2. And you can use your calculator and find what, because without calculator, I cannot solve this equation. I cannot find arc sine of 0, 2. But you can, and you will find the angle alpha. You of course can put cosine alpha here using your calculator, but it would be bad, because you really can find cosine alpha, because this plus this equal 1, so cosine alpha equals 1 minus sine squared alpha, and you can put right away that it is square root of 1 minus u squared over v squared, right? And you can put that it is v squared minus u squared square root, and the bottom would be v. Okay? And so if you plug this number here, you will receive this number. Plugging here, we're receiving d equals v. Instead cosine, we're typing this v squared minus u squared, and on the bottom there should be v. So this v would be gone, and we're receiving and multiplying by t1. And we immediately have this is gone, and we have t1 equals d divided over v squared minus u squared. And we immediately receive this time. And if we compare this time with d over v, we see that this value, we can modify it, d, and factor out v. So it would be v, and here would be square root 1 minus u squared divided over v squared. So you see what happened. We have the same dv, but d over v, but in the bottom there is this value that is square root of the numbers at less than 1, so it would be less than 1, so t1 would be definitely greater than t. So if I divide t1 over t, dv will be gone, but this would be this value, t1, 1 divided on this square root of 1 minus u squared over v squared. We can put the numbers if you want, and we will receive 1 square root of 1 minus u squared of 0, 2 would be 0, 0, 4. Would be 1 over square root of 0.96. So this would be a little bit higher. Time t1 would be a little bit higher, and there is no surprise, because we actually moving in this direction with significantly, not significantly, but vy is equal v cosine alpha. And this is a smaller number, so we're moving across with a smaller speed, because we direct part of our board speed towards fighting this u. In previous solution we were not fighting u, we just were moving straight for the shortest time possible. But here we're directing our speed here, so we're spending the part of our speed to fight u, and another part becomes smaller. This part in this direction is smaller than v because it's multiplied by cosine alpha, and cosine alpha is always less than 1. And here, part of it, we're creating the speed that fights this drift u. Okay? So this is the first thing that we know. We now know time, and we know that time is this, but we can also find the angle. Find the angle and find this distance L, or distance S. And for that, let me wipe it out and say that S divided over D, S divided over D is tangent alpha. And tangent alpha is sine alpha divided over cosine alpha. And so we know that S equal D sine alpha divided over cosine alpha. And all we have to do is to find that sine alpha is u over v. So we put d u over v, and cosine alpha, we already found it, but I removed it, but let me draw it again. Cosine alpha would be square root of 1 minus sine squared alpha, so u squared over v. And so we put this cosine alpha here, and this would be d sine alpha u, which is good, v, and here we put cosine alpha like square root of 1 minus u squared over v squared. Okay? So we have this formula here, so it's exactly like this. But when we have, after that, we have to divide it on square root, which is a small number. So S becomes a little bit longer. So actually, this is not correct. And if you plug the numbers here, you will see that S is bigger than L. And that's because the time of our crossing is bigger. And so for the time of our crossing, we have to fight the same drift u, and that means that we should point higher than otherwise we would be drifted down. And that's the result. So, watch it again if you didn't understand, but it is pretty straightforward. And again, x, y, constant speed, movement in this direction, movement in this direction, and in that particular case, this is a linear motion along this line, and it is reflected in the fact that there is no speed along x, because we're actually pointing higher, but we're moving straight across in perpendicular way. So, because those speeds are equals out, there is no movement in this direction. So, on one hand, we described it with a two axis independent motion. On another hand, it turns out that it is straight motion along one line. So it's a little bit twisted, but that's what it is. And absolutely, the time would be longer, and we should point higher than L. So, if you liked it, click like, subscribe, bell, question your problem. See you next time. Thank you.